Okay, welcome back, class. And today we're going to do an example. And so in this video we're going to do an example of deciding, hey, how do we know whether something's a function or just a relation? Okay, so we've got three relations here, and we're asked to determine whether these relations represent a function or not. Okay, so here we go. So F. Look at F. So we've got, again, look at the x values, and do we have any repeated x values? So the answer is no. So this is a function because we can't have, we don't see more than one y value for one x value. Okay? So one way of looking at this is look at a set of numbers like this. So if we have a set, and we've got this set here, we'll call this the domain. Okay? And in the domain, these are our x values, right? And so we've got 1, -2, so 1, -2, and 3 in the domain. And then we've got what we're going to call here the range, and these are the y values. Oops. So these are the y values. Okay, what are the y values? We got 2, 4, and 4. So we got 2 and 4, right? Okay, now, what I'm going to do is I'm going to draw arrows from the x values in the domain to the y values in the range. And so 1 goes to 2, -2 goes to 4, and 3 also goes to 4. And so the question is, okay, does this represent a function? Well, the answer is yes. But now we can visualize it because as long as one value, excuse me, as long as each of these x values goes to only one, as long as one arrow goes to only one value in the y, we're good. So this only has one arrow, right? Going to 2. This -2 only has one arrow going to 4. And this 3 only has one arrow going to 4. It's okay if two different x values go to the same y value. That's okay. Okay? What we can't have is one x value with two arrows, or more than one arrow going to two different y values. Okay? So now let's look at this one here, G. So this again is a relation. Okay? So notice as soon as so one way is to just look at the ordered pairs and find and see if you can find two x values that are the same. Okay? So right away, I see these three values. Right? I see G here, 1, 1, and 1. Notice that 1 is going to three different places. This is not a function. It's a relation, but it's not a function. So how would I represent this? Well, I'm going to create my domain again. And so I'm going to have 1 and 2 in the domain. And here's my range. Okay, and now what I'm going to do is I'm going to put 1, 2, 3 in the domain, or in the range rather. So 1, 2, 3. And so now 1 goes to, oops, let me do my, here 1 goes to 1, 2, and 3, and then 2 goes to 3. Okay, now, what does this in is this. Okay? This is what violates being a function. Okay? This is okay, this is not. So it's a relation, but this is not a function. Okay, now let's look at the last one. Okay? So now here, I've got, again, oh, here we go. I got two negative values. I got two values of x that are the same, but they have different y values. So this is not a function. Okay? So again, let's visualize how this is. So this is -4 and -2. And now I've got 1 and 0. And again, as you see, we've got -4 is going to 1. And then -2 is also going to 1. And it's going to 2. So again, this is where we run into trouble. Okay? Can't have that. Okay? Now another way to look at a function to see that this is how a function needs to operate is this way. So what I can do is I'm going to draw, look at a function as like a machine. Okay? And so if we look at, let me do this. So if we look at a machine here, so I'll call my function machine. Okay? And so this is my function of x. And so what happens is you can think of the independent variable x as the input. Okay? And then what comes out at the bottom, which is y, is the output. Okay? So a function works this way. If you put x in here, then you're only going to get one value of y. If you put the same x, you should always get the same y. So for example, let's do f. Now, the f function here, let me call it capital F of x. Okay, since this is a function. Okay, we'll call it f of x. Now, so that means, hey, if I put a 1 in, I'm going to put 1. And when I put in 1, what should I get out? I should get a 2. Okay? So I should never get anything other than 2. If I put a 1 in, I'm going to get 2. So if I put a 1 into my function machine, I will always get a 2. I'll never get something else. Right? So if I get something else, my machine's not working. There's something wrong with my machine. The function's not working. Or in other words, it's not a function. So for example, g is not a function because, hey, if I put in 1 into my machine, I could get 1, 2, or 3 out here. That would not work to be a function. Function means if I keep putting 1 in here, I'll always get 2. I'll never get anything other than 2. Okay? Okay, that's it.